Assalamu alaikum everyone. Welcome to another video of Chemistry with Sarab Tasambeg. In this video, we're going to talk about the effect of pressure and temperature on the volume of a gas. Since in one of the previous videos, we have studied that gases are compressible, of course, we will apply a pressure and the volume of the gas will be reduced. So let's look deeper into this concept of the effect of pressure on the volume of gas. The relationship of pressure and volume was proposed to us by Boyle's. The Boyle's law states that pressure and volume are inversely proportional given temperature constant. So if I draw a P versus V graph, the pressure and volume would be inversely proportional, but in this case, the temperature is constant. So pressure is inversely proportional to volume, given temperature is constant. The other law is Charles's law. Charles' law has explained to us that volume and temperature are directly proportional given pressure is constant. So volume and temperature are directly proportional given pressure is constant. This is Charles' law. Now let's look deeper into Boyle's law and explain it in terms of kinetic particle theory. So when we say that I increase the pressure, so increase in pressure, so I'll just write an upward arrow. An upward arrow would indicate an increase in pressure. Keep in mind, you can't use this upward arrow in the exam. You can't write that in the exam. So an increase in pressure reduces the volume because gases are compressible. Gases are compressible. And when force is applied, the particles of the gas come closer together reducing the spaces between them and decreasing the volume. Keep in mind that when I increase the pressure and the volume reduces, the temperature of the gas stays constant because pressure and volume are inversely proportional when temperature is constant. In the case of Charles' law, when I increase the temperature, the volume of the gas also increases because the particles gain kinetic energy. Because we studied in one of the previous videos, the temperature is directly proportional, or it's the average measure of the average kinetic energy of the particles. So because the particles gain kinetic energy, and will move away from each other, overcoming their forces of attraction, and thereby increasing the volume. Keep in mind that when you increase the temperature and the volume also increases, the pressure would be constant. The pressure would not change. So volume is directly proportional to temperature given pressure is constant. For example, this is a balloon, right? And it has some air, helium gas in it. If you increase the temperature, if you start heating the balloon will start to expand. So as the temperature increases, the balloon extends, the volume also increases. So the volume of the gas will also extend. But the pressure inside both the balloons will stay constant. The pressure inside both of the balloons is staying constant. That's the beauty of it. Let's look at this case. Pressure. This is my piston. and this is my helium gas. When I apply pressure on this piston, the volume reduces. The piston goes down and the gas contracts. The volume reduces. So the piston will go down, will apply force, and the gas contracts. So increasing the pressure reduced the volume of the gas, but the beauty of it is the temperature here and here would be constant. Both will be T1s. The temperature will be constant in both of the container. So that is the effect of increase in temperature and pressure on the volume of the gas. And of course, why is this happening? Because gases are compressible and gases can also expand. So in this case, increase in temperature is expanding the gas, and in this case, increase in pressure is contracting the gas. In the next video, we're going to start a new concept, which is the concept of diffusion. Until then, stay tuned. Thank you, everyone.